Do you know why is it called equilibrium? Chemistry learn with fun with your lovely teacher or mentor Siksha ma'am.
Hello my dear lovely students. How are you? I hope you all are fit and fine and stay safe at your home. Today I am going to teach you a new topic. This topic I picked up from class 11th. Many students called me and messaged me, please ma'am, send your video on this topic. So this video is for my lovely students. As I always ask you, before learn any topic, you have to understand the concept of the topic. And our today's topic is equilibrium. Now, your first question should be, ma'am, what is equilibrium? What is the meaning of equilibrium? Don't worry, I will explain. First, I give a small definition about equilibrium. Then I explain and elaborate this topic. Okay, equilibrium. Equilibrium is a condition in course of reversible chemical reaction in which no net change in the amount of reactants and the product. Before we learn in detail what is equilibrium, we have to know about the reaction. What is reaction? Anyone can know? Yeah, you have to know. What is reaction? When two reactants react each other and give any product. In very simple language, that is reaction. Okay. Now I ask a question. क्या रिएक्शन सिर्फ एक ही टाइप की होती है? Reactants reacts and give product? No. Reactions has types. Reaction. How many types of reaction? Reaction has two types. First is irreversible reaction and the second is reversible reaction. Now you will ask me, what is irreversible reaction and what is reversible reaction? Very simple. I will explain irreversible reaction and reversible reaction in 4 points. If you remember this point and if you understand these 4 points, I definitely say you will never forget difference between the irreversible reaction and the reversible reaction and what is the meaning of irreversible and reversible reaction in your whole life. Okay, now let's start about irreversible reaction. Irreversible chemical reaction. When we fried egg, it is impossible to unfry the egg. A lot of reaction works in the same way. Irreversible chemical reaction is a reaction which proceed only in one direction, from reactants to product, and products do not have tendency to reform the reactants. Irreversible reactions happens only in forward direction, not in backward direction. In such sort of reaction, reactants reacts and give product. There is no change in the product. The most important factor is in irreversible reaction. Products could not create reactants. And the last point, in irreversible reaction, we can't find equilibrium. Okay. For example, magnesium ribbon is burnt in presence of oxygen to give magnesium oxide 2 Mg plus O2 2 MgO. Second example, silver nitrate AgNO3 is added to sodium chloride NaCl to give silver chloride and sodium nitrate. AgNO3 plus NaCl, it gives AgCl, silver chloride precipitate, and sodium nitrate NaNO3. Another example, calcium carbonate CaCO3 reacts with dilute hydrochloric acid to form calcium chloride, carbon dioxide gas and water. CaCO3 plus 2HCl, CaCl2 plus carbon dioxide gas plus water. Reversible reaction. The reaction in which product can be reconverted into reactant are called as reversible reaction. In these reactions, both forward and backward reaction take place simultaneously. Reversible reaction represented by two full-headed arrow to half-headed arrow but in opposite direction. Reversible reaction in which reactants formed products can revert and products formed original reactants. Reaction proceed in either direction. We use double-sided arrow sign. For example, when we place ammonium chloride in a boiling tube, heat on a flame, ensure that reaction should happen in closed vessel. Ammonia and hydrogen chloride both are corrosive gases. Remove boiling tube from burner and let it cool. Have a look. We will see that the white crystal on mouth. These are ammonium chloride crystal. So, what has happened here? Ammonium chloride has thermally decomposed into ammonia and hydrogen chloride. Formed ammonia and hydrogen chloride have reacted each other and produced ammonium chloride. Therefore, this is a reversible reaction. Now, we come to our main topic, that is chemical equilibrium. Equilibrium we can get in two types. First is static equilibrium and the second is dynamic equilibrium. Now, what is static equilibrium? Static equilibrium. This is we read in physics. Static equilibrium we understand by an example. We applied a equal force from both sides on a box. The box won't move. That condition is called as static equilibrium. Okay? Now the second is dynamic equilibrium. Chemical equilibrium is also known as dynamic equilibrium. So what is dynamic equilibrium? When reaction is going on but there would not be any further changes in the reactants and the product, that is dynamic equilibrium. In short, speed of forward reaction is equal to speed of backward reaction is represented the dynamic equilibrium. Okay, I would like to explain dynamic equilibrium by an example. Imagine we take a bucket and open a tap for filling this bucket. But if I do a hole on the bottom of the bucket, so what will we see? We will see bucket is filling by the tap. But on the other hand, the same amount of water coming out from the hole, which we do on the bottom of the bucket. Now, at the end of this process, finally we got an equilibrium point, and at this equilibrium point, reaction is going on, process is going on, but the concentration and the amount of water inside the bucket would be constant. I'll explain chemical equilibrium by the graph in different criteria. First is rate of reaction versus time. In this graph, we will see initially rate of forward reaction is high, and with the time rate of forward reaction is decreases. Simultaneously, initially rate of backward reaction is lesser than the forward reaction, but gradually the rate of backward reaction will increase. After some time, both reactions will reach at that point where rate of forward reaction is equal to the rate of backward reaction. This time we get equilibrium in the reaction. After getting equilibrium, the rate of forward reaction and the rate of backward reaction will be the constant. Now understand? Now we will come to our next graph. That is concentration of the reactants and product versus time. What happens in this graph? Initially, concentration of the reactants is high. Why? Because initially reaction is not going on. So we don't have any type of product. But when reaction is started, after some time, the concentration of the product gradually increases and the concentration of the reactant gradually decreases. But when we get that point, which point? Equilibrium point. At the equilibrium point, both concentration of the reactants and the concentration of the product, it would be the constant. There would not be any further changes in the concentration of the reactants and the concentration of the product. Now, clear? If you have any doubts, so please write your comments and write your questions in comment box. I will definitely give you answers. So this is very much clear that reaction is going on. This is a continuous process, but at the equilibrium point and after getting the equilibrium point, the amount of reactants and amount of product will be equal. There would not be any changes in the concentration. If product form any type of precipitate, so that precipitate wouldn't be changed. That is the equilibrium point where we can't see any further changes in the reaction.
Let's see characteristics of equilibrium.
First, we have seen the first characteristics of chemical equilibrium, that is dynamic in nature. It means rate of and speed of forward reaction is equal to the speed of backward reaction when forward reaction and backward reaction is happening in the product and forward reaction and backward reaction is going on, not stopped at all at the equilibrium point. First is dynamic in nature. Second characteristics is equilibrium can be achieved from either side. It won't be affect equilibrium point.
For example, ammonia decomposes into nitrogen and hydrogen.
Clear? Now the next characteristics. Initially, concentration has no effect on the relative concentration of the equilibrium. Equilibrium point will remain as such at the given temperature. Okay. Now, at the equilibrium point, color has to be constant. At the equilibrium point, pressure has to be constant. At the equilibrium point, temperature has to be constant. At the equilibrium point, density would be constant. Concentration of the reactants and concentration of the product, this is also constant. There would not be any changes in any condition. Now, the next and very important characteristics of equilibrium, that is equilibrium can be achieved or equilibrium can be attained only in closed vessels, not in open area, not in open vessels. Now, for example, A plus B gives C plus D, where D is gas. If we do this reaction in open vessels, what we will see? We see just because of D is in gaseous form, D will escape from the vessel. So we can't get equilibrium, even we can't see reversible reaction, because reversible reaction happens where the reactants reacts and give product, and after some time product reacts and give reactants. If D will escape, then how we will get A and B? Understood? That is very important, that equilibrium reaction occur in closed vessel. Finally, it is impossible to get equilibrium in open vessels. There should be a closed vessel for equilibrium reaction. Clear? Now the next characteristics. Next characteristics is role of catalyst. Role of catalyst is very important. Another characteristics of chemical equilibrium. I will explain role of catalyst by an example. If you want to cross a hill, or if you want to go on the other side of the hill, what will you do? You will go on the top and then you come down from the other side and you reach the other side. If other side of person want to cross the hill, he will also do the same thing. But if we make a tunnel in the center of the hill, so what happened? One side of the person can easily go from the tunnel to the other side, and the other side of the person can easily go to the other side of the hill. A catalyst play a role in the chemical equilibrium reaction as a tunnel, where by the catalyst the rate of forward reaction is faster than before, and rate of backward reaction is also faster than the before, and we will get equilibrium point. The person met quickly when where they meet after the reaching on the top. They will take much time, but after using the catalyst we will get equilibrium point earlier than the normal reaction. Now clear? After learning the characteristics of chemical equilibrium, now we come to our next topic, that is types of chemical equilibrium. There are two types of chemical equilibrium. First is homogeneous chemical equilibrium and the second is heterogeneous chemical equilibrium. Now, as I always ask, what is homogeneous chemical equilibrium and what is heterogeneous chemical equilibrium? First, homogeneous chemical equilibrium. In homogeneous chemical equilibrium, the reactants and the products all are in same phase. For example, hydrogen gas reacts with iodine gas and it gives hydrogen iodide gas. Reactants, both reactants are in same phase, that is gaseous state, and the product is also in same phase, that is gaseous state. Homogeneous equilibrium is also divided into two parts. First is where the number of molecules of the product is equal to the number of molecules of the reactant. For example, 1 mole of hydrogen reacts with 1 mole of iodine gives 2 mole of hydrogen iodide, where the number of reactants molecule is 2 mole and the product molecule is 2 mole. Second type of homogeneous reaction in which the number of moles or molecules of the reactants is not equal to the number of moles or molecules of the product. For example, 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas and gives 2 moles of ammonia gas. Here
all reactants and products are in gaseous form, so this is homogeneous chemical reaction. But the second type of homogeneous chemical reaction where 4 moles of reactants gives 2 moles of product. Here we can see number of moles of reactants is not equal to the number of moles of the product.
Now, the second type of chemical equilibrium is the heterogeneous chemical equilibrium. This is very easy to understand that what is heterogeneous chemical equilibrium. In heterogeneous chemical equilibrium reaction, where the reactants and the products all are not in the same phase. Simple. In homogeneous, all are in same phase, reactants and the product. Best example for heterogeneous chemical reaction, that is when the calcium carbonate solid decompose into calcium oxide and carbon dioxide gas, where calcium carbonate is in solid state and the calcium oxide is also in solid state, but carbon dioxide is in gaseous form. Okay. Now, my dear students, you learned in this video about chemical equilibrium, types of reaction, irreversible reaction, reversible reaction, types of chemical equilibrium, what is dynamic equilibrium, and characteristics of equilibrium. You understand by the graph, you understand by the examples. If you have any type of doubt, please send your questions and ask freely in the comment box. I will definitely give you the answer. And if you like this video, so please like, share and subscribe, and keep watching this video till the end. Do not take any tension. Keep learning chemistry with fun, with your favorite, with your lovely teacher and mentor, Shiksha ma'am. We will meet next time in next video very quickly. So bye bye. जाते जाते वीडियो को लाइक, शेयर और सब्सक्राइब करना ना भूलें. गुड बाय. हैव अ नाइस डे. हैव अ नाइस लाइफ.
Stay connected with Chemistry Learn with Fun and bell icon को दबाना ना भूलें.